Well, hi, people. We are on the third piece of this lecture on introducing color. And now we're going to talk about dyeing. And dyeing is just the process of using a compound to add color to a material. So we talked about grayish goods, right? So something that was unfinished. So it could not have a topical solution on it, or it could not be dyed or colored. So that's what we're going to talk about in this section of the lecture. What is a dye? A dye is a complex organic compound that is used to add color to a fiber or a textile by binding with them, so by combining with them. And currently, most dyes that are used are synthetic, and synthetic dyes are just complex colorants that are usually derived from some hydrocarbon. We'll talk about the science next. And in the first part of the lecture on colorants, we talked about Mavine, which was the first synthetic dye and how it was created by mistake. And it's a very vibrant, rich purple. But there are natural dyes, and up until 1856, dyes were all natural. And again, natural dyes are complex colorants, and they're just derived from a natural organic source. So, oftentimes they're plants. Saffron. Saffron makes an orange color. Um, you can dye with tea and coffee, onion leaves. There are quite a few things that you can dye with that make more subdued or muted colors. Then there are animal inks that you can dye with that make more rich colors. Some of the original purples were actually inks that are derived from mollusks and sea creatures. And then there are rocks and minerals that you can add to a garment to alter its color. So um, there are both. There are both that are used, but for the most part, synthetic dyes are used now because they are mixed with a colorant, right? Mixed with another agent that makes the color stay. So there's color fastness. There is no wash down or very little wash down. Um, there may be some wash off when it's originally created, but very little wash down. So next slide, we're going to talk a little bit about the science. I promise I'm only going to talk about the science. I'm going to get it all in on one slide. Didn't know you were going to get this much science probably in textiles, but it's funny because there are some areas it's just not called textiles, it's actually called fabric science. So let's talk about the science as quickly and as simple of terms as I can make it. My husband actually is a chemistry professor, so he enjoys hearing me record this part of the lecture. But a dye is composed of two basic types of molecules, and one is the chromophore, which is the colored portion of the dye molecule, so the part that actually puts color. And then the oxochrome is the other molecule that slightly alters the color. So the oxochrome is what gets continually put in to make variations in the color, right? Dyes need to be soluble. So soluble means they need to be dissolved in water. So remember when we talked about pigments were not soluble. They did not dissolve in water, and dyes do dissolve in water. And they have to dissolve in water in order to bind to the actual fiber. So remember when we talked about pigments, we said that pigments just sit on top of a fiber or a textile, whereas a dye penetrates the textile or fiber and bonds to it, right? So they become one in one. They become one structure. And like I said, dye molecules have to be dissolved in water or some other agent, some other liquid agent to that enables them to penetrate the fiber. Any undissolved particles of dye that remains outside of the fiber either comes in through the wash off, it comes out or it just comes out in bleeding, right? It bleeds onto an adjacent fabric. It comes off, hopefully it comes off in the wash off before the garment is made. But still, that bleeding that you see sometimes when you wash your darkly colored fabrics the first time or two is part of that process that didn't complete itself. Most dyes do bond chemically with the fiber, and they're found throughout the fiber, even to its interior. If we look at the cross section, the dye is even in the cross section. So when we look at fabrics that are printed with dyes instead of fabrics that are printed with pigments, we can distinguish those two, because, like we said, the pigment sits on top and the dyes penetrate much further into the garment. What's the dyeing process, right? We got to get to the process. The dyeing process, it's just the environment that's created for the introduction of a dye, usually by hot water, or some other hot solvent, steam, something, some heat. So it is a hot process of either hot water, a hot solvent, steam, or some kind of dry heat. And the chemical additives of the dye include, salt, or it may have some acid, something that's going to help the dye penetrate into the fiber or the textile, right? And a knowledge of fiber dye interactions, the methods of dyeing and the equipment that's used produces by knowing these things, you have a better understanding of the color behavior, that the finished product will have. In order for a fabric to be colored, dye must penetrate the fiber. No ifs, ands, or buts about it. And fibers that dye easily are absorbent to the chemicals that are used in the process. And dyes react with the surface molecules first. So in the dyeing process, moisture and heat swell the fibers. That's why all of the processes we use, we saw had water and heat in it, and that pushes, I hate to say it, that makes the science happen, right? That makes the science happen that helps the dye penetrate, that helps the dye get trapped into the fiber. So again, depending on the fiber, depends on the type of dye and the type of polymer, the other chemical that is used. So wool is essentially dyed alongside something that has an acid dye, because that fiber is absorbent and it reacts really well to acids. Dyes are classified or grouped by chemical composition and method of application. We're going to talk about that in a second. I have a table that will be under the lecture, under this video part of the lecture, that we'll talk about. But dye stuffs, so things that make dyes, they're highly complex organic or synthetic substances that combine both chemically and physically with that complex, fiber molecule. And thousands of different dye stuffs are used for fibers and textiles, and not one dye stuff is capable of combining with all textile fibers, right? Since textile fibers are also, chemical substances, they're substances. They have chemical properties. Some dyes, for example, combine really well with the protein, so wool, and not so well with cotton, right? And when a particular dye is capable of combining with a fiber and can impact that color, so impart its color on it, the dye is known for having an affinity for that fiber. So make sure you know that word affinity, right? And, to make what would other, utter chaos, when I say the thousands of dyes that can be used for, the different types of fibers, dyes are instead grouped into dye classes. And dye classes, the table will be under this portion of the lecture. There are a handful of dye classes, and most dyes in each class possess some similar, of course not the exact same, but possess some similar color fastness, color fastness characteristics when they're applied with similar techniques to similar fabrics, to similar fibers and fabrics.